Hey, how's it going, folks? This is Mr. Murray coming to you with a little video on factoring quadratics and introduction. Okay, so in this video, I'm going to be getting you introduced to one of the most important skills that we're going to be talking about in this, one of the final units of the year, and one which we're going to revisit next year in significant detail, and that is factoring. Okay. So remember, last unit we saw three different types of quadratics forms. We saw standard form, which is what you see here up top. We saw vertex form, which at this point we're going to revisit most likely next year. Okay. And we saw intercept form, which is the form you see down below. Now, one of the challenges that we talked about was that we said, look, it's really easy to find the y-intercepts. You just plug in 0 and you're done. That's the y-intercept. But what's difficult is the other way around. That is the problem of finding the x's that make the output 0. So rather than making 0 the input, you now have to figure out what makes 0 the output. Okay, and that's not an easy problem. What you see here on the right is this little Babylonian tablet, and actually, to my knowledge, we've actually discovered that in these Babylonian tablets, they were actually thinking about these very kinds of problems. How do I find the x's that will make this 0? And they, I believe, were able to find a formula, maybe not, and I'm not sure if it's in the way we see it today, but they were able to find a way to always know every single x value that when you plugged it in gave you 0. Or in other words, the x's that made y equal to 0. Sometimes we think about it like that as well. Okay? So also last unit, one of the main skills we did was that it was very focused around standard form when it came to converting. So as I said, as I did in the converting video that I did, and as we did in class, right, we learned how to use the box to convert from intercept form to standard form. Now we're going to go the other way, because remember, like I said, one of the challenges is to find the x-intercepts of this function right there. That is the x's that make y 0. So if I can make it look like this form right here, well, this is very conveniently intercept form, where the x's that make y 0 are right in the equation. So that could be one way to help solve my problem. Not every quadratic is going to break down like this. Okay, so keep in mind, we will eventually need to develop other strategies, but this is actually a very powerful tool. And it's actually, compared to some of the other strategies, including the ones we're going to talk about next year, a relatively lower difficulty solving strategy. And by solving, I mean solving the equation you see here. So it's definitely one that you want to have in your tool belt. All right. So I'm going to go ahead and move on to talking a little bit about the ideas behind factoring. Before I do that, I just want to make sure I make it clear here. This is not meant to be an end-all be-all covering of factoring, okay? I'm not going to cover every single type of example. I will talk about a couple special cases, but other special cases of quadratics may not get covered at all. So this is just supposed to be getting you warmed up to the ideas. I just want to make sure I make note of that, okay? So the first thing I thought I would talk about is unboxing the box. Okay, so what we learned about last unit is that if we had a quadratic that looked like this, I could set up what we call the area model, or the box. And what I can do with that is I can use the area, right? I can calculate the area of each box. And then I can add up the 4 boxes. In this case, there's 4. And what that does is it gets me, okay, a new function, right? It gets me a function in standard form. Now, I know that -7 and 10, right? -7 makes this 0 and 10 makes this 0, right? So I know that my intercepts should be -7, 0 and 10, 0. But You would not necessarily know just by looking at this red one that plugging in -7 and plugging in 10 would get you 0. Usually when we've made tables, we haven't strayed necessarily that far from the 0 when we plug in x's, unless we have some kind of intuition, for example, that it's the intercept that we know to tell us to go out there, right? So that could be a challenge. Now, let's see what happens. If I plug in -7, I get 49 plus 21 minus 70. So that's 70 minus 70, which is 0. If I plug in 10, I get 100 minus 30 minus 70, which is also 0. Okay, so I can confirm it works. So they have the same exact x-intercepts. Now, one thing we looked at in class is I said, how do the numbers 7 and -10 relate to the numbers -3 and 70? And what we found was that it appears that these numbers, okay, that they multiply to 70 and they add to -3. That is, they multiply to the C value and they add to the B value. I'm not going to teach any tricks here when I do this, except maybe the box, because the only thing that's tricky about, and a lot of people teach the multiply and add, again, that method doesn't always work, and we're going to see an example, and I'll show you by the end of this video so you see why I'm not going to push that. So what we need to do essentially is we need to work backwards. We're going to start with x squared minus 3x minus 70, and we want to make it look like this. So what's a few things we notice about this box? Well, one thing I notice is that the x squared is always in the top left, while the -70 is always in the bottom right. That is, the thing that only has x's in it is up in the top left, while the thing that only has the numbers, rather no x's at all, is in the bottom right. And if you think about it, that makes sense, right? This just has x's. Now, sometimes there will be a number in it, but for this one, for example, there's no x in the 7, and there's no x in the -10, so you wouldn't expect there to be an x here. So maybe what I know is if I'm factoring it, that when I'm going to start, I know that x squared goes here, and I know that -70 goes there. And so if I know that, what can I figure out about the other sides? Well, I know this needs to be x, and this needs to be x, because otherwise, how would you get x squared? Now, how can I get 70? Well, there's a few ways. I would probably start, if I was going to make a list, I'd probably start, to be honest, with 10 and 7, because that would be, to me, the most straightforward one. You could do 2 and 35. Those multiply to 70. You could do 5 and 14, okay? And so, or, I mean, you could also do 70 and 1, okay? And so, I could try to plug to some of these in and see if it works. So I know they have to be a -70, which tells me one of them has to be a negative number, and one of them has to be a positive number. So let's say I had chosen -7 and 10. -7 times 10 is -70. So let's see what happens. I get 10x minus 7x. So, okay, wait a minute. This is 3x, not -3x. Okay. So I made a mistake. I gotta check. And you know what? That's okay. Because what that getting the not right answer did is it gave me a sense that, wait a minute, it was just a -3 instead of +3. So maybe if I make the 10 the negative and the 7 the positive, then that's when I'll get what I want. And when I do it out, I get -3, which tells me that x squared minus 3x minus 70 is the same thing as x minus 10 times x plus 7, which means whatever makes the standard form 0 has to also make the intercept form 0, because they're equivalent, right? Every point that's on 1 is also on the other. And so what I know by looking is that 10, 0 and negative 7, 0, because they're the intercepts of the intercept form version, have to also be intercepts of the standard form version. So that quickly makes figuring out one of the most difficult parts of standard form a lot more straightforward, all right? But this factoring tool is essential. Okay, so if any of that was difficult to digest, I definitely recommend you go back and rewind and make sure you understand what I kind of did here. I encourage you to use the timestamps in the description below. But then in a moment, I'm going to actually move on to some problems here. All right, so I'm going to get started with an I try here where I need to factor this quadratic. So in this, I'm going to factor, and I'm also going to tell you what makes it equal to 0, because those are two important skills. Remember, the unit we're going into is quadratic equations. So there's no equal sign here, and there really should be. Okay. So I need to turn this into intercept form. Factor to factor means to break a quadratic down into a product of two other polynomials. This is a polynomial, right? It contains multiple different items or terms. So I'm going to break it down into one thing times another thing, right? Just like how I could break down, for example, 6 into 2 times 3. 2 times 3 is our factors of 6, because when you multiply them, you get 6. Okay? And also, these will be factors of this polynomial, because when you multiply them together, you get that polynomial. So just like numbers have factors, so do quadratics, which is a pretty cool thing. So let's say that I'm going to make a box here. What do I know? Well, one thing I know is I know that when I factor this thing, x squared is going to end up here, right? You can imagine, right, that when I do this box out, the final answer needs to be x squared plus 5x plus 6. So what would that box look like? Well, we know from our experience that x squared is going to be in the upper left and 6 is going to be in the lower right. So what would the outer part, right? We're trying to find the outer part. So what would that have to look like? Well, up here, I'd have to have an x, and to the left, I'd have to have an x, because that's the only way to multiply and get x times x, which is x squared. What about 6? How could I get 6? Well, I could do 1 and 6. I could do 2 and 3. And that's really the only combination, because 6 and 1 and 3 and 2 are the only other ways to do it. So let's say I try 1 and 6. If I try 1 and I try 6, I get x, I get 6x, so those add up to 7x, not what I'm looking for. Okay, so it's not that. Notice I'm choosing positive numbers, and I'm using some intuition here. First of all, I know that this number, this last c value here, is a positive. And so I know that the only way that I'm going to multiply and get a positive number, right, when you multiply two numbers, if you get a positive, either it's a positive times a positive or a negative times a negative. But what I know is I also have to add those numbers to get the b value. And if the b value is positive, well, the only two negatives are not going to add to a positive. Two positives will. So that's how I know that I'm choosing a positive 2 and a positive 3 rather than a negative 2 or negative 3. Because some people would ask, well, Mr. Moray, doesn't negative 2 times negative 3 also equal positive 6? And it does, but only when you choose, right, -2, -3 equal -6 when you multiply them, but only when you have it with a positive setup do you get the +2 and the +3, which when you add them, add up to 5. So what we get for an answer is that x squared plus 5x plus 6 is equal to x plus 2 times x plus 3. And if you want to check your work, you could expand this out. You could imagine distributing the x to the x, the x to the 3, the 2 to the x, the 2 to the 3, and you're getting x squared plus 5x plus 6, and you can see that is what you started with. Okay? Now, let's say I wanted to figure out what would make this 0. So what are my x-intercepts? Well, what plus 2 is 0? That would be -2. What plus 3 is 0? That would be -3. Okay, so I hope this example made sense. Again, I encourage you, if you were confused by anything here, to go back and ensure you understand the answer. Again, the answer is, if I ask you to factor, this is what I'm asking you to give me right now. Okay, because this is as factored as you can get it. Eventually, we'll talk about what I mean when I say factor completely. This is factored completely, but for now, when I say factor, this is what I'm looking for you to do. This is find the x-intercepts, okay? So again, please make sure you understood what I did here, and then in a moment, I am going to go ahead and move on to the next problem. All right, so here's another one that we need to factor here. So I'm going to, again, factor this, but I'm also going to go for the intercepts as well. Don't forget about those. The intercepts are important. Remember, that's part of the reason why we're doing this. Okay, so here we go. So I have x squared minus 8x plus 12. So again, I know that if I was going to make a box, and I'm asking myself, when I'm factoring, what had to go on the top and the left so that when I multiplied and I did this all out on the inside and I combined like terms and I simplified, what I got was x squared minus 8x plus 12. The first thing I know is that, again, my x squared is going to be right here. And I know my 12 is going to be right here because these are going to be the things that only have numbers, and the things without the x's are the only thing that can give me the answer without the x. If you think again about the distributing, if x is in anything that you're multiplying by, chances are there's going to be an x somewhere in the product, in that part of the product. At least that is. Here's another thing I noticed. I noticed that while this number c is positive, this number b is negative. So remember, when you get a positive by multiplying, either you multiplied a positive by a positive or a negative by a negative. My apologies. So, which of these, when you add them together, will give you a negative? It's going to be the negative and the negative. So if you can do this additional step that I just did, it's helpful because it again gives you a sense of how to set it up and think about what numbers would I look for. Well, I know this is a negative and this is a positive, so I need two negatives so that they'll multiply to a positive and add to a negative. Now, I can assume that these are both x's because that's the only way to get x squared in this case. And now I need to analyze 12. So I need to think about what's going to multiply and give me 12. So I've got 1 and 12, I've got 2 and 6, I've got 3 and 4, and then 4 and 3. So those are my combinations right now. And the factors of 12, by the way, are 1, 2, 3, 4, 6, and 12. Okay, so I can see that if I plug in -1 and -12, they will multiply to get 12, but then when you add these, you're going to get -x and -12x. That's not going to work out. But notice when I do 2 and 6, watch what happens. When these combine, you get negative 8x. Now, you don't need to test every single combo. If you can already see one that works, go for it. If you have intuition that 112 is a bad guess, go for it. But 112, having the 1 be one of them, comes up surprisingly when you wouldn't think about it. So also don't count it out. But again, if you see one that works, don't feel that you had to test the 112 as I did, okay? Because remember, you want to get to the right answer, and if you don't feel that you want to plug in things you know are wrong, I accept that. Now to turn this into factored form. So here are my factors. It's equal to x minus 2 and x minus 6. And this is the factored. This is factored form right here, also known as intercept form. So this would be the answer. Now, if I then said, find the x-intercepts, which by the way we also sometimes call roots or zeros, because they make y 0, what you would say is, well, what x would make the first piece 0? It would be 2. What x would make the second piece 0? It would be 6. So see, it's so straightforward. I hope you believe me that it's really, really straightforward to find the intercepts when you're here, when you're on the right. Intercepts are great right here, okay? And when you're on the left, it's not obvious at all. You'd have to take shots in the dark. Now, could you get to 6 eventually? Sure. But again, by the time you master the idea of factoring, you'll be able to factor like this. And in the time it takes you, I bet you, to get the vertex, I guarantee it, even the time it takes you to get the x of the vertex, I bet some of you could actually factor it just as fast and find the intercepts and get the x that way. That is, to know that the x has to be 4 because 4 is in the middle of 2 and 6. Okay, when you gain a really strong level of mastery and competency in factoring, you will be able to factor really, really quick. I promise you, if you're willing to put in the time, you can get there. But just like some of the other stuff we've been doing, especially recently, you have to be willing to put in the time if you want to get the correct answer in that. All right, so please make sure you understood what I did here, and then in a moment I'm going to move on to one that we're going to do a little bit of trying together on. All right, so here we go. Now I'm going to factor this quadratic right here, and even though it's an I try, I'm going to try to get some of your feedback here as well. So if we think about it, we're going to start with the what? We're going to start with the box. All right. So I know my x squared is going to go where? Here, box 1, box 2, box 3, box 4. Which one? Box 1, box 2, box 3, box 4. X squared is going to go in box 1. Negative 20 is going to go in box 4. In that case, I'm just using that so that you can get it, so that you would have an answer. So what's going to go on this? We're going to have my x and my x. And now negative 20, well, I know that one of the numbers is positive and the other number is negative, because that's how you get a negative. A positive times a negative is a negative. They can't both be positive, because you can't get a negative when you multiply two positives. And they can't both be negatives, because you can't get a negative when you multiply two negatives. Also, and I only say this because A is 1, it seems like the negative number is further from 0. And I know that because the positive is, when I add it in, the positive product part, because like, right, one of these is going to be positive and one of them is going to be negative, right? This is going to be one like term. This is going to be another like term. the positive is not going to, let's say this was the positive, is not going to be strong and not big enough to pull the total number of x's out of the negative. So I know the negative number is going to be further from 0. So how can I multiply and get 20? Well, I could have 1 and 20. I could have 2 and 10. 3 doesn't go in. I could have 4 and 5. And that is the only ways I could make 20, at least with numbers less than or equal to 20. So now what I'm going to do is think about which one of these is going to get me the negative x. And I know the 2 and the 10 and the 1 and the 20 are too far away from each other to ever be able to be that, cancel to get negative 1, especially because, again, a is 1. So I'm going to go with negative 5 and positive 4. So I get negative 5x and a positive 4x. And when you add these up, you get negative 1x. So my factored form is x minus 5 times x plus 4. That's the answer if I say to factor it. If I ask for the roots, intercepts, etc., we know the intercepts are 5, 0, and negative 4, 0. Okay, so again, please make sure you understood what I did here. And then in a moment, hopefully you're starting to get a little bit of confidence. We'll move on to the next one. All right, so I'm going to start going a little bit faster now. We're on to the we try. So I need to do x squared plus 2x minus 15. So the first thing I do, right, is I set up the box. So please make sure you set up your box. Now I'm going to put in my numbers. So I know my x squared is going to be here. My 15 is going to be here. Because you remember, we know we're going to multiply two things together. And we're going to get this, right? This represents the area. And I'm trying to find what length and width would give me that area. So I'm basically taking educated guesses based on, again, the patterns that we've seen so far. Okay. So how do I get x squared? What am I going to put here? This is going to be my x and my x. Now let's make a list of our 15 factors. So we have 1 and 15. And I'm going to ignore the negative, right? I'm just shooting for the 15. 3 and 5. That's it, folks. That's really it, believe it or not. 2 doesn't work. 4 doesn't work. 6 doesn't work. 7 doesn't work. 8 doesn't work. 9, blah, blah, blah. Really, and this is true, once you get up to essentially half of the number, you're not going to find any more factors. So let's say if I'm at 15, I go to 7. Once I get to 8, I'm done. Because if I could have found one on the upper side, then it would have had a partner on the lower side. Okay? It's just like maybe like a little number sense thing. That's like a rough explanation of it. Okay, so 1 and 15, I'm not going to be able to get to 2, right? Because I'm going to have to be essentially adding 1 and 15. But here's what I know. This is negative. So one of them needs to be positive and one of them needs to be negative. So which one is going to be negative, the 5 or the 3? How can I get a positive 2 by adding? If which one has got to be the positive for me to get a positive 2 when I add the things together? Is it 5 or 3 that's going to be positive? It's going to actually be 5. Okay, hopefully you said 5. Because when I have the 5 and I take the 5 and I subtract the 3, that's when you get 2. So my final factored form is x plus 5, x minus 3, and my x-intercepts are negative 5, 0, and 3, 0. Okay, so please, if needed, go back and make sense of what we're doing here and make sure you understood what was going on. And then in a moment, I will go ahead and move on to the next problem. All right, so the next problem is another one for us to try. There'll be, remember, all kinds of problems here. And again, feel free to choose the ones that are most relevant to you. Again, I really do hope you do the U-tries that are a little bit later on down the line. Okay, so again, here we are factoring. What am I doing first? First, I am setting up my box. What's going in the top left? X squared, bottom right. 56, up top. X and X. And now I need to make 56. How can I make 56? So I have 1 in 56. 2, and half of 56 is 28. 3 doesn't go into 56, and I know that because if I add up the digits, 5 and 6, I get 11, and that's not a multiple of 3. 4 does go into 56. 4 goes into 56 14 times. Okay, because if you take, and you know what I did? I took a 2 out of 28, made it 4, right? 4 times 14 is the same as 2 times 28. All right. 6 doesn't go in because if 6, for 6 to go into it, 2 and 3 would have to. 7 goes into it 8 times, and that's the end of it. So if you see the numbers pair that's going to make this work, amazing. See if you can see. One of these pairs will be the pair. See if you can figure it out and see if you can make sense of which of these 4, 1 and 56, 2 and 28, 4 and 14, or 7 and 8, is the pair. Think about why that is and think about which ones have to be positive and negative and why. Okay, so hopefully what you said was the combo was 7 and 8. And if you add 7 and 8 together, you get 56. Rather, you get 15. And if you multiply 7 and 8 times together, you get 56. So I have x and 7 and x and 8. You may do a plus. If you want, it's not required because it's a positive. If it was a negative, I would be a little bit more concerned. So this one's going to give us x plus 7, x plus 8. And then if I ask for the intercepts, they'd be negative 7, 0, and negative 8, 0. And I suppose 0, 56 as well. Okay. So hopefully that made sense to you. Again, if you need to rewind to make sense of this, I encourage you to do so. And then in a few seconds, I will move on to the next problem. All right. So here's my first one for you to try. I know you can do this. So I'm giving you a quadratic. What I want you to do here is I want you, just like we've done, to write it as an x plus something or x minus something times x plus something or x minus something. In other words, turn it into intercept form. All right, so what I want you to do, take a look at this. Think about how we've done it in the past problems. Rewind if needed. Right, and so pause the video. Try to factor this and then unpause and we'll see if you're right. All right, so here we go. We'll set up our box. I know I've got an x squared here and a positive 40 here. Now I know I need to get 40, and this is a positive, and this is a negative. So what I know is that the two numbers I'm looking for both have to be negative. And that's because a negative times a negative is a positive, but a negative plus a negative is a negative. Okay? Also, I need to see how 40 breaks down. So I get 1 in 40, I've got 2 and 20. 3 doesn't work. I've got 4 and 10. I've got 5 and 8. 6 doesn't work. 7 doesn't work. 8 goes with 5. And once I get that loop around, I'm done. And now I look and I ask myself, well, I know that above the x squared and to the left of the x squared I have x's. What are my numbers going to be? How am I going to get negative 13 knowing both of them are negative? Well, this would give me negative 41, negative 22, negative 14, and there we go, negative 13. So I have to choose negative 5 and negative 8. And if I choose that, I get negative 5x and negative 8x, which when added get negative 13x. Now, if you get it wrong, it's great, because you know what you do? You just erase it. You just erase the numbers you plugged in. You go back. You choose 2 more numbers, and you're good to go. But here's the thing. This part up to here, we know is correct. So if you put numbers here and here, and the box doesn't work, the only logical conclusion is that one or more, or that is one or both of the numbers you chose, should not have been chosen, is not a valid combination. Okay? So you need to ensure you think like that, and you're pretty solid with factoring. So what we should get is x minus 5. This is an important skill, okay? X minus 8. And then if I ask for intercepts, it'd be 5, 0, and 8, 0. Okay, so again, please make sure you understand how I did that problem. And then in a moment, I will move on to the next problem. All right, so here I got an interesting one. Notice this last number is a pretty interesting number here. It doesn't have too many factors. So again, I'm going to ask you to please take a moment, and I want you to take this, I want you to turn it into intercept or factored form using the method we've talked about in this video, okay? So please try to factor it. All right, so pause, try it out, and then in a moment unpause, and I'll show you how to solve. Alrighty, so here's the deal. I got my box. I'm ready for my box. Okay, so we know we got to set that up first. So at the very minimum, you got to have that, right? Hopefully you've caught on to the fact that basically these all follow the same pattern. And if you can understand that pattern, it's going to help you out a lot. So this is the pattern. The x squared is always top left, and the number is always bottom right. Okay, in this case, because of how these are set up. And that is generally true because, again, the biggest power only comes from multiplying the things with the biggest power, and the number only comes from multiplying the things that don't have a letter with them. Okay, so now I think about how to get 49, and 49 is cool because 49 is a perfect square. So the only factors of 49, the only way to do it is 1 and 49 or 7 and 7. And so the only way that's going to work is that these both have to be 7 because I need a plus 14. So what I get is x plus 7 times x plus 7 or x plus 7 squared. And interestingly, this is really starting to look like vertex form. And so next year, what we're going to think, if we think about this, if you have it as a square already, then you can just make it into a square by factoring, in this case, x plus 7 squared, and it's in vertex form. Look, it's got a vertex of negative 7, 0. Okay, so here's the thing. What if we could add some numbers when it's not a square to complete the square? If we could do that, then we would have that coveted square that you see we have here. So that's an important skill, that completing the square, and you'll see that next year. Okay. And again, this one, if I ask you for the x-intercepts, only one, and it's negative 7, 0. So see that this one only has one x-intercept. All right. So please make sure you understood this. And then when you're ready, I'm going to go ahead and I'm going to move on to the final problem. All right. So I'm going to look at two last examples, okay? X squared minus 4 and 2x squared minus 5x minus 3. On the left, what you might notice is that b is missing. This is going to be one that we could think about solving with factoring. It is a good one to be able to factor and helpful to be able to factor. But if I wanted to make this a 0, there's actually another method we're going to learn this year that's actually better and easier than factoring, but that's okay. So if I was going to factor this one on the left, I'd have to think about, they have to multiply to negative 4, but where's x? How many x's do I have? Right? I don't have any. So they have to multiply to negative 4, right? But add to 0. Well, when I add two numbers and I get 0, if I get 0, what do we know about those numbers? Well, one thing we definitely know is that one of them is the opposite of the other. So for example, 3, if one of them was 3, the other would have to be negative 3, and vice versa. If one was 17, the other would have to be negative 17, and vice versa. Okay? So you see where I'm going here. So what two numbers that are opposites could multiply to negative? Well, if they're essentially the same number, but one's positive and one's negative, then what I'm looking for is actually the square root of 4. And the square root of 4 is 2. Now here I'm going to do x minus 2, and here I'm going to do x plus 2. So this is what we call a difference of squares. And so when you have a difference of squares, it's called a difference because you're subtracting. And it's a difference of squares because each of these are perfect squares. X squared is x times x, and negative 4, and rather 4, is 2 times 2. Okay? All right, the last example I'm going to work with is one where a is more than 1. This example, as I promised in the beginning of the video, is the reason that the add and multiply, whatever, don't work. The first reason they don't work is because I can't think of any combination of numbers that adds to negative 5 but multiplies to negative 3. Yet this one is possible to factor. Again, my number one strategy is when you go back to it, this was also the answer to a problem, right? Again, envision that at some point someone did a box and 2x squared minus 5x minus 3 came out of that box. Okay? You did it all out and that's what came out. So what do I know? Well, I know that this had to be my 2x squared and this had to be my negative 3. Okay, well, how could I get 2x squared when I multiply two things together? Well, one of them is going to have to be a 2x, and the other one's going to have to be an x. Because if I multiply 2x by x, I've got this invisible 1. So I have the 2 times the 1 giving me the 2, and I have the x times the x giving me the x squared. So that is my first piece. And now, how do I get negative 3? Well, it's not just a matter of multiplying and adding. For example, a lot of times that won't work. In this case, it's going to be easier because I know that negative 3 and 1 is the only way to make it work. But here's the problem. In most cases, it doesn't matter whether I put -3 here or whether I put -3 here, for example. But when you think about it, if I put -3 here, it's going to get multiplied by the 2. But if I put the -3 here, it's going to not get multiplied by the 2, right? It's only going to get multiplied by the x. So where I put the numbers matters. And I need to put my -3 here so that 2x times -3 will give me -6x. And then my 1 will go here to give me x. So everything comes together. I get 5x. And my factored form is 2x plus 1, x minus 3. Okay? And when a is bigger than 1, that is a very important case of what we're working with here. Okay? All right, so definitely a lot to unpack here. I do hope you found this video to be helpful. I know there's a lot to this one. This is supposed to be just kind of an introduction to quadratics with kind of some things to think about and a number of examples. Keep the questions coming. You know, keep thinking about the big ideas as we move into the new unit. And by the way, if you're looking for the intercepts, this would be, you'd end up getting negative. So this would be -1/2 0. And the other one would be 3 0. Okay. So anyway, keep the questions coming. All right. I love the positivity. You know, keep trying, keep working at it. And remember, you can do it. All right, folks. Thanks for watching. Have a wonderful day. And don't forget to love math.